Welcome to ISCW Lab Number 2. In ISCW Lab Number 2, we're going to examine how we can securely send data between a couple of corporate sites that are interconnected via some sort of an untrusted network. And by an untrusted network, I'm talking about something such as the internet, maybe a service provider's network. Specifically, we are going to set up a site-to-site VPN, a virtual private network. In fact, one of our objectives, our first objective, is to discuss and review VPN theory. And when we set up an IPsec virtual private network on the routers, we could do that using the command line, using iOS. However, we're going to take a different approach in this lab. We're going to use a GUI interface into that router called SDM, the Security Device Manager. In order for us to access that on the router, we need to go in and issue a few commands on the router to prepare the router to support this SDM access. Then, via a browser, we can securely access the router's Security Device Manager, its SDM interface. The SDM interface, it has several different options, and one of the options is to set up a site-to-site VPN. We can do this in a wizard-like format where we fill out information and click the next button. That's the way we're going to do this. Once we have configured this virtual private network tunnel, we want to verify the tunnel status just to get confirmation that we can indeed securely transmit information across an untrusted network. First up, let's review exactly what this VPN is going to be doing for us. There are different types of VPNs, different protocols that we can use for our VPNs. We are specifically going to be focusing on an IPsec, an IP security virtual private network. This can do several different things for us. One of the things it can do for us, it can make sure that as data is transmitted from one side to the other, for example, take a look at the 192.168.0.0 network hanging off of fast Ethernet 0/0 on router R1. When that subnetwork transmits information over to the 172.16.3.0 network hanging off of Ethernet 0 on router R3, we want to make sure that that data has not been modified in transit. That's one of the things that an IPsec tunnel can do for us. Something else it can do, it can scramble the information up. It can encrypt the information so that if someone in the middle in that untrusted network were to intercept our packets, they would not be able to make any sense out of those packets because they're scrambled up. So information that we send into router R1 as clear text is going to be scrambled using an advanced encryption algorithm, so if it were intercepted inside of that untrusted network, it would be unreadable. We are then going to decrypt that information at the far side as router R3 sends that information out to network 172.16.3.0 at the far side of the network. In order to prepare our router, specifically we're going to be doing this on router R1, in order to prepare router R1 for SDM GUI access, we need to set up router R1 as a web server. We can go in and say, in global configuration mode, IP HTTP server. This enables the web service on the router. However, we probably want to connect using HTTPS. In order to enable secure HTTP access to this router, we will probably enter IP HTTP secure-server. We give this command in addition to the previous command. Once we do that, we need to specify that when someone is connecting to this router via the web server, the way we're going to authenticate them is using local authentication. In other words, we can give a username and a password locally in the router's configuration that can validate an incoming secure HTTP session. In order to set up one of those username password combinations, we can use a command such as this. We can say username followed by the username followed by privilege 15. That's the same as the enable privilege on a router. When you go into a router and you say enable, and you give the enable secret password, that privilege level that you enter into, that's privileged level 15. We are then going to use a specific password for that user. We're going to say secret 0 followed by the password. And secret 0, that simply means that this password is unencrypted. Next up, we want to possibly download the SDM software. On some of our newer Cisco routers, such as the 2800 series routers, iOS may come with the Security Device Manager already installed inside of the router's flash. So we may not need to do this depending on your router platform. However, if SDM is supported on your router, and it's not supported on every router, you can download SDM from Cisco's website, assuming you do have appropriate credentials, you have an appropriate service agreement, and you have permission to do this download from Cisco.com. Assuming you do, the URL on screen shows you where you can download SDM from. And on this page, there is also documentation, and this documentation lists not only how to set up SDM, it gives you a listing of routers that support SDM. For example, we're going to be running this on a 2611XM router. That's one of the router platforms that supports SDM. However, I also have a 2610 router. SDM is not supported on that platform, so please make sure you understand on what router platform SDM is going to function correctly. Let's go out to router R1 and prepare its web services so that we can access SDM via that GUI interface. Let's configure R1 to act as a web server. That way we can access SDM via a browser. To do that, we say IP HTTP server in global configuration mode, but let's go a step further. Let's set up secure HTTP. To do that, we will enter the command IP HTTP secure-server. And we get some feedback on screen that the router is generating RSA keys. We need to understand when we do authentication using the router is not going to be pointing to any sort of external CA. A CA, that's a certificate authority. We're going to be using a self-signed certificate. We're going to go in and create a user account to do authentication as we log in. And notice the feedback we have on screen. We're being told to issue a write memory to save the new certificate. The write memory command, that's a legacy command that used to be used in iOS to copy the running configuration to the startup configuration. Today we would probably enter copy space running -config space startup -config. However, this does give us an excellent reminder that we do need to save our running configuration to the startup configuration. To set up the router to locally authenticate, we give the command IP HTTP authentication local. That configures local authentication as the method for accessing this HTTPS server. Now we need to give an account and a password that we can log in as. We say username, and let's use a username of Kevin, and we'll say we want to log in with privilege level 15. That's the privilege level that we log into when we give the enable password typically. Let's now say what the password is. We say secret 0, meaning this is an unencrypted password, secret 0, and let's just make the password Cisco. And I'm using a very simple password for training purposes. However, in the real world, you would want to pick a much stronger password. At this point, we have enabled web access to this router. Let's now launch a browser and point to a valid IP address on this router in order to access SDM, Cisco's Security Device Manager. Let's enter the IP address of 192.168.0.30, and let's give that name that we just created. It was a username of Kevin, and it was a password of Cisco. We go ahead and log in. We're prompted as to whether or not we want to use HTTPS. Let's say that yes, we do want to use secure HTTP. And do we want to trust this certificate? Because it's not signed by a certificate authority. Remember that we're using a self-signed certificate. We're forced to log in again. We give the username of Kevin and the password of Cisco to get into the SDM interface. And while we wait for the page to load, just a reminder, SDM, it comes installed by default on some of our router platforms. Other router platforms that support SDM, we might have to go out and download those SDM files and then copy those over to Flash from a TFTP server. Depending on the version of Java we're running, we may be prompted again to say whether or not we want to trust this self-signed certificate. We can say yes we do for this session, we can say no, or we can click always to say yes, in the future I always want to trust this self-signed certificate. And by the way, there are a couple of ways we could access SDM. One way is to do it as we are doing, accessing it in the flash of the router. Another way is to install the SDM files on a PC, which saves flash space on the router. We're now finally logged in to the Cisco Router and Security Device Manager, which we call SDM for short. What do we want to do? Well, we want to configure a site-to-site VPN. We give SDM a few more moments to finish loading all of its modules. And the first thing we want to do is to configure a site-to-site VPN. Notice the buttons along the top of the SDM screen. One is configure. That's what we want to select. Let's say we want to configure, and then in the task list of things we can configure along the left-hand side, let's say that we wish to configure a VPN. So we go down and we select Virtual Private Network, a VPN. That's what we wish to configure. And there are different types of VPNs that we can configure. Let's say that we want to create and configure a site-to-site VPN. That's what we're doing in our scenario. And you might see that we could create a site-to-site VPN or create a secure GRE tunnel over IPsec. Let's just leave it at create a site-to-site VPN. And we click the Launch Selected Task button. We can either do a quick setup or we can do a step-by-step wizard. To illustrate the options, let's do a step-by-step wizard. Let's select step-by-step wizard and then click on Next. At this point, we're asked to specify the interface on this router, on router R1, that we wish to protect via IPsec, that we wish to form a tunnel on, and that's going to be interface serial 0/0. We now need to specify who is at the other end of this VPN tunnel. We're going to specify the other end using a static IP address. In our topology, that's router R3. Router R3 has an IP address of 10.2.2.2. And we could do authentication using digital certificates or pre-shared keys. In this case, each router is going to have statically configured a pre-shared key of Cisco Press in this example. We enter that and then we re-enter it and click Next. We next configure the IKE proposals. IKE, I-K-E, that stands for Internet Key Exchange. And these IKE proposals, they specify how we're going to do encryption, authentication, and how we can securely exchange a shared key if we are in fact going to be exchanging that key over the untrusted network. However, in our scenario, we are going to have that key statically configured on each router. And these parameters need to match up with the parameters on the router at the other end of the tunnel. Let's define a new IKE proposal. In order to do that, because we already have one existing IKE proposal, we click on the Add button, and first of all, notice the priority. In which order will we be trying to use these IKE proposals? The one that was already created had a priority of 1, so let's leave this at a priority of 2. What type of encryption are we going to be using? DES is what we're defaulting to. Let's change that. Let's make the encryption a little stronger by using triple DES, 3 DES. Next is the hash algorithm. A hash, think of that like a fingerprint. A hash can verify that data was not modified in transit. Here, let's just leave it at SHA-1. Security Hash Algorithm 1 is what that stands for. And then, when it comes to authentication, we're going to change this from RSA SIG, we're going to change that to pre-share. Remember, we're going to have a shared key. We're going to have a key that is statically configured on router R1 and also on router R3. If we were exchanging these keys, could we do that securely over the network? There's a way to do that. It's called Diffie-Hellman. What type of Diffie-Hellman we select is our next option. We're defaulting to Diffie-Hellman Group 1. Let's make that a bit stronger by specifying Group 2. And let's just leave the lifetime. How long are these keys valid for? We can leave that at the default of 1 day, 24 hours. Well, I think we're done with this. Let's go ahead and click OK. At this point, we have now set up our IKE parameters for router R1. And the VPN peers at each end of this tunnel, they need to agree on these IKE parameters when they begin this IKE session. You might also hear IKE parameters referred to as an IScw policy. IScw. That stands for Internet Security Association and Key Management Protocol. Let's next create a transform set. A transform set is going to determine what sort of encryption and authentication methods are going to be used to protect the traffic in the tunnel. To add a new transform set, let's go ahead and click on the Add button. Notice we already have one transform set, a default transform set, pre-configured for us, but let's go in and say that we wish to add a transform set. First of all, we're going to name it. Let's simply call this Kevin's underscore transform underscore set. There are other options available on the screen. We can see some additional options by clicking the Show Advanced button. Let's go ahead and click that. But looking back up at the integrity algorithm, that makes sure that our data has not been altered in any way as it travels through the network. In this example, let's select ESP SHA HMAC. Next, the encryption algorithm. The encryption algorithm, that is what scrambles our data up so that if it were intercepted by an attacker, that attacker would not be able to read it because it's all scrambled up. The encryption algorithm we'll use will be ESP triple DES. And after we reveal the advanced options, notice we have different modes for this tunnel. There is a tunnel mode and a transport mode. With tunnel mode, we're encrypting the original IP header and creating a brand new tunnel header. But transport mode, that only encrypts the payload of the packet, leaving the original IP header intact. Let's leave this at the default of tunnel mode. At this point, the transform set is all looking good. Let's click OK to add it. Let's make sure that that is the transform set that we have selected. Notice from the drop-down menu, select transform set. Notice we have selected Kevin's transform set. Everything looks good there. I think we're ready to move on in our wizard. Let's click on Next. And we now define what traffic it is that we want to protect. What we want to do is to protect all traffic traveling between the subnet hanging off of router R1's Fast Ethernet 0/0 interface. That's subnet 192.168.0.0 with a 24-bit subnet mask. Let's enter that under the local network information. We specify 24 bits in the subnet mask. For the remote network address, there let's enter 172.16.3.0, again with a 24-bit subnet mask, and click the Next button. At this point, the SDM site-to-site VPN wizard is giving us a summary of our configuration that we just went through. If we scroll through and verify that, yes, indeed, everything looks as expected, we can click the Finish button to apply this IPsec configuration to router R1. It looks like the configuration has now been successfully delivered to the router. However, in order for this to work, we have to have a complementary configuration applied to the router at the other end of this tunnel. Notice that right now the VPN tunnel is down. The VPN tunnel is not up. That's because the other side, router R3, has not been configured. The great news is we don't have to go through this entire process again on router R3. Instead, check this out. We can click on the Generate Mirror button, and it's going to take the configuration we've applied to router R1 and intelligently restructure it so that it would be applicable to router R3 to a peer device of 10.2.2.2. We do need to do a bit of editing on this text file, so let's save it out first of all. It looks good. Let's go ahead and click on Save. Let's save it out as a file. Let's just call it R3 Mirror. And then we can click OK to close this Generate Mirror window, after which we will go out and open Microsoft Notepad. Let's open Notepad, edit that mirror configuration so that it is applied to the appropriate interface on router R3. You see, that's one thing that this Generate Mirror function could not know. It would not know what interface we wanted to apply this IPsec configuration to. Specifically, the terminology we're using is a crypto map. So first, let's delete this disclaimer at the top saying that we should not use this configuration exactly as it is. We need to edit it. Let's remove that. Then, let's go down and see what the name of our crypto map is. It looks like the name of our crypto map is SDM underscore CMap for crypto map underscore 1. It's that crypto map that we need to take and apply to the interface on router R3 that we want to protect using IPsec. And on router R3, again, that is going to be interface serial 0. So let's select this configuration so that we can paste it in to router R3's configuration. Let's do a copy, and then let's open up our terminal emulator, get moved over to router R3, go into global configuration mode, and let's paste this configuration in. Notice all the time we're saving by being able to just paste in this pre-configured configuration thanks to SDM. We now need to take that crypto map and apply it to interface serial 0. We go into interface serial 0, followed by the command crypto map, followed by the crypto map name, which was SDM underscore CMap underscore 1. At this point, we have created our IPsec configuration on both routers R1 and R3. And to make sure things are operating correctly, SDM gives us an option to test, to verify this VPN tunnel. Let's go back over to the SDM interface and take a look at one of the options that SDM gives us. SDM allows us to click on the Test Tunnel button. Right now it still says our VPN is down, but let's test this VPN tunnel. And do not be concerned if it fails the first time. Let's go ahead and click on Start to test the VPN tunnel. It says that the tunnel status is currently down. Everything seems to be configured correctly though, but at the end we will notice that we still have an issue. It says the tunnel is not up. Do not be concerned about this. What we need to do, we need to say that yes, we want to continue, except this time we will educate SDM about a specific IP address in that remote network that we want to test connectivity with. It already knows about the 192.168.0.30 on our side of the network. Let's enter an IP address of 172.16.3.1. That's the Ethernet 0 interface on router R3. Now that we give it an actual living, breathing IP address, let's try to test this tunnel again. This time, I've got a feeling we're going to be successful. Let's give it a few moments to complete its test. Making sure that it can securely send traffic between these two Ethernet networks. One hanging off router R1, the other hanging off of router R3. Takes a few more seconds to complete the test. Checking the tunnel status is now up. Look at this, great news. It says VPN troubleshooting is successful. The VPN tunnel is up. Great news. At this point, here's what we can do. We can securely send traffic between the 192.168.0.0 network on router R1 and the 172.16.3.0 network on router R3. One other thing we should do before we exit this lab, as a best practice, let's go to both of our routers and save the configuration. Let's copy the running configuration to the startup configuration. We do that on router R3 by saying copy space running hyphen config space startup hyphen config. Let's move over to router R1. Do the same thing there. Let's save this configuration, something important for the real world as well as in the exam on simulation style questions in the exam environment. On router R1, again, we do a copy running hyphen config startup hyphen config. At this point, I think we're done. I think we have secured traffic across this untrusted network. Let's review where we have been in this lab. In this lab, we took a look at an iscw topic. Specifically, we took a look at configuring a site-to-site virtual private network using IP security. We began by discussing what a VPN could do for us in terms of giving us confidentiality and assuring the integrity of the data that we were sending from one site to another site. We discussed how we could prepare the router to support SDM access via a GUI interface using a browser. We took a look at how we could then go out and open up that SDM GUI interface on the router, and we used the site-to-site VPN wizard to configure our IPsec tunnel. Once the tunnel was configured and we took the configuration from router R1, we generated a mirror configuration, applied that mirror configuration to router R3, and we had to do a little bit more modification on router R3. Remember the crypto map. We had to take that crypto map that got generated and apply it to router R3's serial 0 interface. Once we did that, we verified that the tunnel was up. And we also mentioned that after we have completed our configuration in the exam environment as well as in the real world, it's important to save our configuration. So we copied the running configuration to the startup configuration.